Introduction to Digital Systems. Hi folks. We are here to discuss and get to know something about digital electronics. In this chapter, we are going to discuss what is a digital system. Where are they used? What are logic gates? What are K-maps, their types, and implementation of K-maps? In this tutorial, we are going to discuss digital systems and their advantages. First of all, do you know what we mean by digital? We commonly use the word digital in computing and electronics, especially where real-world information is converted to binary numeric form, as in digital audio and digital photography. Let's see the difference between digital and analog. Digital means signals are represented either by 0 or 1. 0 means low signal, and 1 means high signal. Whereas analog means that signals vary continuously. Before getting into digital systems, we will discuss the common topic called computers. Do you know how computers are made? Well, people started saying that computers are made by showing some stuff and all. Initially, it begins with silicon dioxide. By using some chemical methods, this silicon dioxide is converted into pure silicon. This silicon is a semiconductor. We can make this silicon conduct electricity, or we can make it stop conducting. This method can be used for making switches. These switches are the heart of digital systems or circuits. If you use a bunch of switches, you can make a chip. If you use a bunch of chips, you can make some circuit boards. And finally, if you use a bunch of circuit boards, you can make some digital system like your own little companion named personal computer, or PC. Not only computers, many digital systems are made by using these chips and circuit boards. And this is how the digital systems are also related to VLSI. Very large-scale integration, that is, chip designing. We are going to discuss that throughout this course. Now, we have come to know that computer systems are constructed of digital electronics. That means that their electronic circuits can only exist in one of two states. They're either on or they're off. As we discussed earlier, digital means zeros and ones. So let's discuss how we are deciding that digital means zeros and ones. Most computer electronics use voltage levels to indicate their present state. For example, a transistor with 5 volts would be considered on, while a transistor with no voltage would be considered off. However, not only computer hardware uses voltage. CD-ROMs, for example, use microscopic dark spots on the surface of the disk to indicate off, while the ordinary shiny surface is considered on. Hard disks use magnetism, while computer memory uses electric charges stored in tiny capacitors to indicate on or off. These patterns of on and off stored inside the computer are used to encode numbers using the binary number system. Because of their digital nature, a computer's electronics can easily manipulate numbers stored in binary by treating 1 as on and 0 as off. We will talk about the binary number system in the next tutorial. This was a brief introduction about the growth of digital systems or digital electronics. I hope you have an idea about digital systems and their many uses. Now, here are a few exact definitions for digital systems. Digital systems are nothing but electronic systems that use digital signals. A digital system is an interconnection of digital modules, and these digital modules are nothing but digital circuits. These are used in communications, business, medical treatment, internet, and many other commercial, industrial, and scientific enterprises. One of the best examples for a digital system is our general-purpose digital computer, which we discussed earlier. A digital system represents information in discrete symbols. Most systems use just two symbols, denoted by binary digits, or bits that are zeros and ones, to represent all information, and these systems are constructed from three basic components. They are logic, memory, and communication channels. Logic operates on symbols. Memory stores the symbols. Communication channels are usually wires, where information will move to the required place so that values generated by logic in one location can be stored in memory. Overall, digital systems are being used more than analog systems. Do you know why we're using digital systems more when compared to analog systems? Well, it's because digital systems are accurate and reliable, and they are surprisingly fast and cheap as compared to analog systems. Now we will see some of the advantages of digital circuits, which are frequently used in digital products. They are easy to design. They can store information easily. Digital circuits are less affected by noise. More digital circuits are fabricated on IC chips. Basically, digital circuits are classified into two types: combinational circuits and sequential circuits. We will discuss combinational circuits and sequential circuits along with logic gates in detail in upcoming tutorials.